I want to be able to just build the game, concentrate on my idea, and leave the distribution and just have it work from day one on anywhere that I want to release.
Hello everyone, welcome to the Game Engineering Podcast. Today I am joined by Amir, who is an indie game developer, most well known for his game A Dark Room, but also he's the creator of DragonRuby game toolkit. And it's really called Game Engine, but it serves the same purpose. It helps you create games, 2D games, and with Dragon Toolkit you can do it incredibly fast. So fast that, in fact, Amir, being an incredibly skilled engineer, is doing a live demo during this discussion. So if you'll be listening to the audio version of this podcast, make sure to switch to the video, at least for the demo. And without further ado, let's meet Amir. So let's start with our discussion on DragonRuby. And let's start with an overview so that we all know what is DragonRuby.
Yeah, that sounds good. DragonRuby Game Toolkit. It's a commercial game engine. It's 2D, and it's cross-platform. Like that's the biggest thing about DragonRuby is that when I was building games, I wanted it. As an indie developer, I tell every indie developer out there, if you're an indie developer, you need to release cross-platform day one. Right, you're leaving money on the table if you don't do that. So DragonRuby Game Toolkit is a cross-platform 2D game engine, and the goal for me, like with respect to the engine, was I want a single code base. I don't want OS fragmentation. I don't want different conditionals and different functions for accessing file system on this one versus that one and aspect ratio. And so that's kind of the linchpin of the engine itself. And the other facet of DragonRuby is that it's a hot loaded environment, fast iteration, fast iterative loop. But short version, it's a battle hardened, beginner friendly, 2D game engine that that can actually do cross platform distribution.
And when did the DragonRuby project started?
So I actually first started developing the mobile port for Darkroom back in 2013, and it was using a Ruby runtime called Ruby Motion, and that's kind of where the core of DragonRuby started. And so I started with the Ruby code base, and then started in 2013. After that, I ported Darkroom to Android, so that happened around 2015, 2016. This was after a few commercial titles, and then the Nintendo Switch release happened for Darkroom. And what Ruby Motion ended up becoming was this cross-platform runtime. So I kind of like privately worked and developed on this API and this idea starting in 2013. Then we officially released in 2019 after the Nintendo Switch release of a Darkroom.
So six
So
six years. Did I count
yeah,
that
6 years.
properly?
It was like 6 years of I guess I like to think of engines and libraries, like the best engines and libraries that I've worked with are always extracted from production code. So
Okay.
you have developers that you're like, oh, I'm going to build this thing or this library to help me build this other product that I have. And I guess the way that I took it was I built enough games over that initial inception to say, all right, here are the common things that I want in the game engine. Here are the challenges. So the extraction process, I would say, was from 2013 to about 2017, and then I partnered up with Ryan Gordon and Alex Denisov, and then we started development on the actual like core codified runtime around 2017. They're released in 2019.
Yeah. So you with Ryan and Ryan C. Gordon, right?
Mm-hmm.
And
Yeah,
the
Ryan C. Gordon,
other member.
Alex Alex Denisov. He's our compiler engineer
Okay.
for
Uh,
for the runtime.
and as three people work on DragonRuby.
Mm-hmm.
Is
Yep.
it by the way active development, like day job development? Is it like after hours development? How
Oh, this
does
is
it?
yeah. I've been doing full time indie dev for
Okay.
the past 10 years. So like, yeah,
Okay.
this is my full time deal from that perspective.
Okay.
And so eh, we've actually, I mean, we just celebrated our fifth year anniversary so far. So as far as feature complete, we're in a pretty damn good place. I guess our next big target is actually cross-platform shaders, not shaders that work in just one platform, not OpenGL that is a deprecated rendering pipeline on Mac OS, iOS, not OpenGL Web 4.0. OpenGL 4 that doesn't work on WebGL. An actual shader solution that is cross-platform on those native runtimes and native GPU pipelines.
Yeah.
So that's our big push for the continuing future.
So before we dive into technical details, maybe can you tell me a little bit more about the motivation? Because you alluded to this already, but I know that you're
Yeah,
kind of like
yeah, I
this
think
is important point.
it's really important for me. I mean, I'm a solar dev. I'll bring in occasional help or collaborations from outside as needed, but um, I don't have the capital and I don't have the bodies to put against fixing a problem. And when I started looking at a Switch release and thinking wider about cross-platform distribution of games, um, I mean the solutions out there just don't solve the problem, which is I want a single code base that works everywhere, that looks the same everywhere, that scales correctly everywhere, and not have to deal with all the fragmentation issues that exist with all the platforms out there. And that was kind of the motivation, was that there was nothing that fit that problem domain well enough. And it's not to say that other game engines can do cross platform, but it's not that focus of I want to be able to just build the game, concentrate on my idea, and leave the distribution and just have it work from day one on anywhere that I want to release. And so because that didn't exist, that's what kind of forced me to say, okay, I need, if I want to sustainably like continue building games instead of worrying about upkeeps, like with every device upgrade or every new system that comes out, I have to rethink and build something that provides this kind of environment for me. And that was one of the driving motivations for DragonRuby. The other thing that pushed the idea was I don't know, like with game development, I don't know if it's the same for you, but it's an artistic endeavor, right? You experiment, you have to, you kind of play around, and you get that idea, and you can't think about anything else, right? You like, I have to get this idea out and put it on the canvas. And the point of getting the time between getting that idea in your mind to getting something on the screen has to be within that energy, right? Because you've got that like limited moment of inspiration. You want to try to work with that inspiration. So the feedback loop and being able to have an environment that lets you lets you play at the speed that you want to, or create at the speed that your mind is going, was really important. And that was another like driving factor for the engine. Is a hot loaded environment. You make a change, it immediately shows up. State is retained. Those kind of facilities that that help that inspiration continue to go. And just everything out there just didn't have that. There's always this like, okay, I got to stop, press a button, wait for things, show the correct scene, and have it come up. And I think that facet of it was the other driving factor. So the cross platform, and then the feedback loop and the interactivity of an artistic endeavor.
Yeah, for the interactivity, it's the most popular engines, at least, they all target both 2D and 3D, right? So there is
Hmm.
a kind of level of complexity with 3D
Yeah.
that comes like that. It's usually you want to have an editor, usually you want to have things, and uh, because now in Dragon Ruby Game Toolkit you're working within 2D environment, you have a niche. I'm not sure how many other engines are targeting 2D, by the way,
Yeah,
but
I think like engines that I primarily looked at or that kind of fall in that envelope. Love 2D is a 2D engine. Um, uh, there's a Defold has primary like 2D facilities, and I know like you've got the other engines that can do 2D and 2D in their 3D environment. But yeah, for me, the biggest challenge in my thought process was it goes back to the idea of like extracting from real world code. Is like I haven't built a 3D game, and I think like I've I, I think I'm going crazy anytime I think about people like solo devs creating a 3D game. I'm just like, it takes me 2 hours to make five sprites look right. I mean, imagine a 3D rig and a 3D model and having a large character space. So from indie motivation, from commercial sustainability, the the facet of 3D is it I dream about it, right? It's like I want to make Vagrant Studio. I want to do like a demake of like a popular 3D game, and that wheelhouse is something that I I haven't gotten to that point, right? I don't feel confident to say yes, I'm building something that's a commercial endeavor geared towards this like artistic approach in a 3D world. So
And
that was one of the focuses for us going 2D, and a lot of our community members have done like things like with ray casting, and they've done like cool 3D experiments with regards to or 3D games from that perspective. But yeah, full 3D environment, just just the amount of work and development time in a 3D game, it feels daunting from my perspective. Is that something that like you? What are your thoughts? Am I crazy? Like, is this?
I think you can get away with like making 3D game, but solo developer, like a solo developer that handles both the modeling, then like all of the animation in 3D, and like creating the scene and programming and like the design, like the thing,
And
like
setting up the rig,
yes,
and yeah,
it
I think like
it
a team of
grows.
maybe four to five people is kind of a minimum when I think of a 3D game, and they have to know what they're doing. Like when you're talking about four people, you
Yeah.
really need to know your
Yeah, but
stuff to make
now I
something
now
really
I
compelling.
wonder like because that's interesting. All of the engines like the let's say there's this golden three, right? Unreal, Unity, and Godot. They both target both 2D and 3D. Like they're not trying to be, for example, the best engine for 2D. Like and there is a niche for this, and because what we have prepared, like we want to do a demo of DragonRuby game toolkit, right, with
Hmm.
you in just about a minute. And the speed of development that I saw from you showcasing this to me earlier on, like, this is incredible. And so many people that are doing 2D games in other game engines could use this speed in just
Yeah,
everyday development, even though, but they're using a full blown solution that targets both 2D and 3D, and because of the 3D aspect has so
there's
much
so much
more.
complexity.
Yeah.
Yeah, there's so much upfront complexity. I think another important point that's worth bringing up is that uh, from from a development standpoint, and like the idea here is that I'm dog fooding this engine, right? I'm using the engine to build my games. I mean, like if I don't ship sustainable commercial games, like I go back to you know doing tax software. It's not something I want to do. So when with respect to the engine and how I build out an idea and prototype, Dragon Ruby supports that entire spectrum, right? So you're talking about that initial feedback loop. You start off, you're just trying to build a quick prototype. You're not trying to you're just trying to flesh out an idea. And if you think back to like Celeste, like their initial like game jam thing was done in Pico 8, and then they had to go and rewrite it to actually distribute anywhere. And
Yeah.
it's that that upfront complexity that is limits that initial prototyping phase that I wanted to be able to accommodate, but also not have you rewrite it if you've got something that's working,
Yeah, and
and
by the way,
keeping that entire spectrum is important.
yeah, in case of Celeste, they didn't even go to the 3D engine. Like they sticked with C sharp and the library that did 2Ds because they didn't
Yeah, I
want
think
to
they
have
did.
this. Do you remember the
They did
tech?
mono develop. I think facets of it were done in Unity, but
Okay,
the thing was is that their initial prototype,
okay,
wasn't Pico 8, and a part of me is like, I wish Pico 8 had that entire story for you to say, okay, you start with your prototype here, and then continue development, and it scales with the complexity of your game. And that was something that was important with Dragon Ruby. And I think a lot of the engines out there, they don't think about that initial development phase, and you get all that upfront complexity, and it's tough.
yeah.
It's unfortunate.
So let's do the demo then.
Yeah, let's take a look at what it looks like. All right. Do you want me to share my screen? I think there should be.
Yes,
Yeah, let me present now. Entire screen share. All right, do you see my screen? Okay.
yes,
All right, and the resolution's good.
yes. But the better, the
Yeah,
bigger the font, the better.
yeah. There we go. How's that look?
Great.
All right. So start up the engine, and I'll just put it side by side, and so the initial prototyping. If I do, I'm gonna just put a sprite on the screen, right? So yeah, x 100, y 100, width 50, height 50, and then the path I'll do sprites, square, blue.png. So we've got some placeholder stuff in there, and I save the file, and you see it show up on the screen, right?
And so to be straight, because I think we didn't mention it, but there is a mention in the name. DragonRuby is a game
Hmm.
toolkit where you use Ruby, the language.
Ruby as a language,
Yeah,
and so Ruby, I've done development for I think 25 years at this point. Large swath of languages, and Ruby is one of the most powerful languages I have ever used, and I continue looking at and say there's got to be there's one of the language. Okay, Lisp. You've got Lisp. You've got those specific dialects. I would say Lisp is the most powerful language out there, but as far as like the second most powerful language I can think of, I mean, Ruby is up there, and just for the syntax, I'm basically defining a dictionary right here. So args is kind of your environment, and I'm using the shovel operator, and I'm saying, okay, put put a sprite into this collection.
yeah.
And so those are the properties that exist on that. And with respect to like the complexity of the engine, or scaling of a solution, this thing can take multiple types of objects. But from a simple prototyping, like this is the simplest thing that you could put in there. So if I have, let's say I have a tick count, and I want to mod that by 1280, right? So you can see it. Yeah, you can see it moving on the screen. Let me do args labels, and let's put the actual like frame on the screen itself, so you can kind of see what that value is. All right, so we'll have the tick count displaying, and okay, it's a little small, so let's set it to, I guess, 50 pixels, 60 pixels. There you go. So
And
that's your frame rate.
you're now editing a file that is being used for the game loop, right?
Hmm.
So the equivalent in the Unity would be the update for each of the component, but this is for entire engine. So what you're
Yeah, so
doing,
this is your entry point right here.
yes, and this is triggered every frame. It's called
Hmm.
tick, and it operates on the arguments which you can
Hmm.
get stuff into and then
Hmm.
get the stuff out.
Yeah. So if I do, so we've got this state mechanism that is kind of a placeholder for you to hold on to like any specific game state. So let's say I want to hold on to the actual X position of the player, right? So I can set that to player.x, and if I do, I'll say inputs q. We'll just say left right. So left right will return -1, zero or one depending on which way it's going, right? So we'll say player args state that player dot x is equal to inputs left right, and it's a really slow, so we'll add a speed to that. But there you go. uh,
See, that's one thing that like I'm trying to envision how it would look like if I was using the other engine, right? And in the other engine, you would need to go back pretty much to the code,
mhm,
change it, and then recompile it. And depending on the hot reload solutions, for example, in Unity, you can change things, but
mhm.
some things will be updated, some things won't, and they will break the loop. So the thing that you can rely on this hot reload, and pretty much you've seen that this was not enough for the speed, you need to speed it up. So multiply by a float, and you can do
Yep.
it pretty much instantly. This is super cool.
Yeah.
Like this is super
uh,
cool.
yeah, and another interesting aspect is that we have a built-in heads-up display also. So when you think about when I think about like a built-in an editor for your game, it, like your game is your IDE. I know you think like Blizzard and StarCraft, they have a map editor. They have a dedicated map editor for building out their campaigns. And so this idea of having your game be your IDE and being able to invoke functions and extend your game in itself to help develop the game, it is about that long-term sustainability. But with this heads-up display, you can evaluate whatever code you want uh, within here. So I can define functions. So if I wanted to, we've got some top level functions for resetting the game state. So if you actually want to reset the game state, you can do reset, and it sets your frame rate, back, and it uh, sets your players. So we had our default player state at 640, and so it reset that location. But yeah, then after that, you're just able to update. And as you notice, like game state is retained, so I can change the speed and then just continue working from that perspective.
And what is the information that you can get? Because if you pull up the display, you get
Hmm.
a block of information. What is the information usually that you get from, like, for example, the video backend, the renderer, things like that?
Yeah, so
Okay,
that's some startup information that you
okay.
have. It gives you a rendering pipeline. So when I talk about rendering pipelines, every single OS has a I guess their de facto rendering pipeline, and it's important for a game to render using that rendering pipeline. um, I see whenever I see like an engine say, "Oh yeah, we're cross-platform," and oh, by the way, we only support OpenGL rendering. That's a ticking time bomb. And you're distributing a game, a commercial game that potentially will not work on the platforms that you want to distribute to. And I think that's really important. So that's your rendering pipeline. Our logical canvas is always 1280 by 720. If you do portrait mode, then it's you know 720 by 1280. But you're always working with that logical canvas, and then we do all the high DPI scaling and aspect ratio resolution on our end.
Oh,
So you
so the resolution that you work with is 1280 is 720, but
That's your logical resolution.
okay,
Yes.
and then it
Yep.
will be scaled to different window sizes depending on the.
Yeah. Yeah.
Okay.
So if you notice, this is scaling at high DPI, right? So our native resolution, we're rendering at 1440p. So as far as like texture atlases or sprites that you create, if I you have your blue.png encode, the convention that we use is if you have at uh, at 2x or at 720p, that will, if you have a file with that name, we automatically load those specific values in. So your code
Okay.
doesn't change. You say this is my baseline 720p resolution, and then you can progressively enhance for other systems. And the 16 by 9 aspect ratio, it, 16 by 9 1 from that perspective. build games within there that have different varying resolutions, but the baseline target for 720p and the 16 by 9 aspect ratio was specifically because of the Nintendo Switch. So you go into when you're in handheld mode, you're running at 720p, so that's kind of your minimum resolution. And then from a logical standpoint of always never having to think about uh, the other, I think it's aspect of being a 2D game is that we can think in pixels. So we can say your logical scale is 1280 by 720, and it supports subpixel rendering, especially for high DPI stuff. But you think in that um, uh, logical resolution, and you're good to go.
Okay.
And that consistency helped.
How would this project change if it had more logic, more files, things like in a
Yeah.
dark room you have like a things that only happen after you reach something. So like how would it evolve in terms of the
Oh yeah.
project?
Yep. So usually, well, you'll end up having like some kind of game class that retains your information. So a real simple refactor would be to put that code in here like that, and then uh, your args method, I would set up like a game object, a global game object that tick gets passed into, right?
Okay.
So we'll do that, and you'll notice that my game state is retained because of the environment. Let's say I want to actually reset my game state anytime I save the file. So I can actually just type gtk.reset at the bottom of any file
Yeah.
and save, and it'll reset the game state. So I don't want the game state to reset. Fine, don't add that function in there. I want it to reset. I define the reset function and invoke that in the file. So you end up with a game class, and then if you have separate files that you want to include, you just require you can require them. So I can move that over into app game.rb file. And so if I yeah, game.rb, move that over, I require it, save. All right, I'm good.
Yeah. First of all, your ability to live code is incredible. And like
Thank you,
the
thank you. I've
speed of that, like it's not speed up and it looks like the video I would watch with like
oh
1.25.
yeah, this is real time. And I think it's the it's that aspect of when you can focus in on your solution and you're not having to do these context
Yeah.
switches. it's
Yeah,
it's
the
really
other
great.
thing like that I think I keep mentioning this on this podcast. Like, if you have a small enough team project, you can have conventions that help you so much. For example, the thing that you reset on save, and then you
Mhm,
can comment this out. There's just one line, and
mhm.
it it makes so much if I think how this would need to be created in like other engines when they have their own abstractions layers, like to make sure that it's super easy to switch between them, it becomes so much more complex, and here you're just changing one line, pretty
Yeah.
much commenting out.
And this state variable is available. So if I want to see the value, right? So right now it's I can set it to 100. There we go. My game state is reset. And yeah, based on those conventions, I can create a function called go to final stage if I'm actually testing like a specific thing, right? So I can create a go to final stage method, go to final stage, and I'll set so I'm passing args in args dot state dot player dot x equals, we'll set, maybe
Yeah.
that's what it does, right? So then go to final stage. Is that what I called it? Did I save that file? I didn't save the file. You have to save the file. Wrong
Okay.
number of arguments.
There's
Go
no
to final stage needs to
args.
take an args, right?
Yeah.
So we'll just, because it's just a helper function. So we'll just pass it in globally. I forgot to save again. There we go. I'm on the
Okay.
final stage.
Okay.
You forget to save.
Yeah.
So then like another aspect is like, well, I don't want to have to pass in args everywhere, right? I'm passing it in here, here, and then I have to reference it in all these, different areas. So this is a facet of Ruby itself. There's something called they're called class macros. So instead of taking up uh, I guess an inheritance point, because I want the developer to be able to derive, right? I don't want you to have to pass in like some base object here, right? So we use a class macro that allows you to that gives your uh, component this capability. So here I'm able to remove args from all my little functions, and then your your game, you set the property inbound,
Ah,
and
okay.
you're ready to go.
Okay. And this is like it's already in scope. It's already like
Yep.
pre-loaded. Okay.
Yeah, and then this class macro also defines your state function, your outputs, so you're not having to prefix everything with
Okay.
args. Your debug functions, actually that should work there too. I shouldn't, because the game is already preloaded with args. So if I reset the game and then go to final stage, yep.
Nice. Nice.
And yeah, and that's the live facility of how you would build out a game.
Great. Okay.
Yeah.
Let's end the demo so that I can get your face as well
Yep.
in the frame. Uh,
And we're back.
yes. So we started a little bit on this. You mentioned that you design with like a specific resolution, and then I think there's also FPS set in place, right? That 60 FPS, and it's being
Yep.
run. Like, first of all, again, making these decisions and then not enforcing, let's say, not pushing them on the player, not making it variable, but just having conventions that make sense because it's 2D, for example,
Yes.
it helps so much for majority of the game.
Mhm.
Majority of the games, like projects that will be built on using this
Exactly.
stack. What kind of other conventions or predefined things you have?
Yeah. So our we DragonRuby has multiple threads. It's threading. I always say this in my talks, is like you do these things not because they're easy, but because you thought they were easy. So so like, oh, I'm going to build a game engine. It's going to be a piece of cake. How hard can it be? And then here we are 5 years later. So yeah, DragonRuby's got a bunch of different threads that do a lot of stuff. So we have a render pipeline that's running uh, it's rendering as fast as your refresh rate. So whatever your hardware provides, uh, that's your like UI event loop, right? And so what tick is the tick function that's being invoked is actually running on our simulation thread. And so our simulation is a fixed time step, 60 hertz. So we do all the thread prioritization, and then all the accumulation of drift to make sure that you're hitting 60 fps. And yeah, based on that convention, you know that when you move a player by 10 pixels in a given simulation step, it's going to move 10 pixels in that simulation step. So you get a deterministic simulation, and
Yeah.
you know that given a default game state, given a default game seed, you're going to get the exact same run of the game regardless
Yeah.
on any device. So
To
that was one of those convention things that was really important, and putting into place. The aspect ratio was another thing. You've got your 1280 by 720p and 1280 by 720 logical canvas. We handle all the scaling for you, so you don't have to worry about those facilities. Um, those were, I think, as far as resolutions that we support, our texture atlases have a pretty good convention. You have the at sign and you prefix it with the specific resolution you want to support, and it's from 720 to 5K, 8K. I forget what our top end is, but definitely 720 to to 4K. We've got the conventions in place for that also. Um, I think those were the biggest facets of like thinking about exactly what specific things that we don't want you to have to think about. File access is streamlined. We have we surface functions that let you write a file name. Our file paths are all forward slashes. So app forward slash game.rb, and we handle all the issues with your web isolated storage, Windows file system, persisting that to the correct user settings,
Yeah.
iOS and Android, their isolated sandbox, and it's all based on
There's
that
so
that
many things.
convention.
There's so many things that I wouldn't
Yeah,
think about it.
there's a lot of things you have to think about. There really is, and if you think about like even touch, so if you for touch enabled devices, and people think, oh, it's only mobile, it's like, no, now you've got Steam Deck and you have the Nintendo Switch. And when I was going through the publishing process for Nintendo Switch, that's something that they look at. They say, okay, what games have you released, and have you released a game with touch? I mean, because they have a device that supports touch, and they want developers that understand how to work with those environments. So our touch events are actually rerouted to mouse. So if you do inputs mouse dot click, if someone's taps the screen, we
Yeah.
we reroute that event.
Yeah.
So if you multi-touch, yeah, there's going to be some progressive enhancement there. But as far as like the default baseline experience,
Okay.
those are some of like the quality of life things,
Okay.
and it's all these things you have to think about, and it's a lot.
It's a blessing.
It's a lot.
Can you walk me through from your main script in Ruby to the
Mhm.
OS level? What are the components of DragonRuby toolkit and how these things like interact?
Sure. Yeah, right. So our baseline dependency as far as anything to do with IO with the system is libstl. So if you think about, audio file access, rendering, keyboard inputs, those things are all based on libstl. So well, we started with that as our foundation. Battle hardened library. I mean, Valve, the Steam client is built with libstl. Like it's a thing, and with Ryan being on board, it made sense to have that as your baseline dependency. So we start with that as your baseline dependency, and then the runtime, our initial starting point for our runtime was mruby. So mruby is an embedded implementation of Ruby. Other embedded languages they maybe are like Lua would be an embedded language. So we start with libstl and mruby, and then after that, we with that mruby runtime, we start gutting the core lib and replacing it with these cross-platform facilities that make sure to work on console and web and everything. So you start up your render context with libstl. We fire up our rendering loop. We fire up our simulation loop. We spin up the mruby runtime with our custom patches, and then at that point we wait for tick tick count equals 0, and invoke and then invoke your function from that perspective. And so if you up to that point, that's where everything in args is being populated in that pipeline. So your simulation loop, we go in and say, okay, what new keyboard input has occurred? Are there any new Windows events that we need to reconcile from the render thread down to the simulation thread, and get all that information inside of that args variable and present that to you. And so that gives you the opportunity to insert like values into args, like args.output.sprites. And then once you exit tick, SDL goes in, and our simulation pipeline says, okay, extract all the primitives that they added, queue those up in our rendering thread, and then that is picked up on the next refresh of the screen.
Okay. Okay. So from looking at this from the Ruby perspective, the script, like the tech, then you go to the layer that has your logic written in Ruby. Then
Hmm.
this logic runs in the mRuby, which is, I understand, like sort of like a virtual machine, like Ruby
It's a
runtime that
virtual
will
machine. Yeah,
analyze this. And
exactly.
this process itself is being maintained by the C++ or C uh,
C API. Yeah.
uh, program that runs on SDL.
Yep. And so
Okay.
for our compilation is all done through Clang and LLVM. So as far as C extensions, if you decide to create any C extensions um, for whatever custom stuff that you want, uh, we use Clang to do our binding construction. So you can expose it into your mRuby objects. Um, but yeah, clangs are baseline compilation. We use that for uh, it's pretty great. Like I'm running on a Mac. I know we haven't talked about like setups, but I'm compiling cross-platform on a Mac, and that's entirely because of Clang and that compiler tool chain. As far as like the redistributable, we handle all the pre-compilation for iOS and Mac. So you're not ever compiling
You're
the
not
program.
now you're talking about the DragonRuby as a resource that you can download and run.
Right.
Okay.
So
Okay.
yeah, and that's the cool thing there is because we're using Clang for our dependency tool chain. If you're on Windows, you can when you do DragonRuby publish to create your build exports, we give you a Mac export that just works. You don't
Oh.
need a Mac. You don't need a Mac
Oh, really?
because we do we do all the compilation on our end, and we're taking your main.rb and code assets and applying it into our
Isn't there
I
any
guess
issue
setup.
with like signing things like that that you need
Yeah,
to?
so for iOS for like iOS distribution
Okay.
itself, if you want to go to the App Store, you need to actually have a code sign
Okay.
certificate to actually sign it. There's People are starting to use GitHub Actions for a lot of that stuff, so they'll set up a GitHub action or a build chain for and then load their certs to do that compilation. But as far as the core compilation unit that you would think that you need a Mac to compile
Yeah,
for, we handle that for you.
that's cool. That's cool.
Yeah,
Can I ask you for like two sentences introduction to SDL, because I have this view of a large library that handles so many things, like including audio, but I think especially like graphics, right? And
yeah,
underneath there's like things
it's
like
massive.
OpenGL, whatever, and everybody uses it. Uh,
Yeah.
it's super
So
difficult to
yeah, so
understand.
libstl is it stands for simple direct media layer, and what it does is it provides you a unified IO pipeline. So when I say IO, I mean rendering, audio, input, all those file access, all those facilities of a system. And so if I want to render something to the screen, I call the libstl API. I think it's like SDL create texture, SDL render copy ex, and you give it a rectangle and like SDL surface. But what it does is it renders using whatever GPU pipeline exists for the OS that you're on. So if you're running on Mac, the rendering pipeline behind the scenes when you call that function uses Metal. If you're on iOS, Metal. If you're on Android, uh, I think it's OpenGL 3.0 ES, so WebGL rendering. For web, it's WebGL. Windows is Direct 3D, console, Vulkan, et cetera, et cetera. But you're not having to write those specific shaders or those specific pieces of code. You're calling render the sprite to the screen,
Yeah,
and it does it, which is great. And then same thing with the input, right? You're not thinking about any OS specific APIs for touch input, for mouse input, keyboard input. All that stuff is handled in that normalized and unifying pipeline. And I think that's the big benefit of libstl when it brings to the table, is it abstracts away the operating system.
okay.
Sorry, that was more than two sentences. I know.
That's fine. That's fine. Also, like as an alternative to STL, at least in my regard, you have a Raylib, but Raylib is, I think, already a bit higher level. It does, uh, it does already more than SDL, right?
Yeah, I think Raylib before 5.0, so after 5.0 came out, it pushed this idea of having modules for cross-platform, cross-platform API support. But yeah, Raylib, at least from my understanding and its initial assumption, was learning how to build games
Okay.
and with a simple C API, and just understanding how to build games using C. And it evolved to a point where its API does support these different platforms. I think it's been less than a year since that happened. But yes, Raylib is another example of a dependency that could potentially replace our SDL. The considerations you want to think about there is is there console support, right? So that's
Oh,
the first question that you need to ask, is that yes, these rendering pipelines exist for these OSs, but what about those things that you need NDAs signed for? You built this entire game, you've got okay, you have approval to go to console. What are you going to do? What are you going to do if those backends and that polyfill doesn't exist for that console? You can build it out if
yeah.
you want, but it's a lot of work.
Okay.
Um, so that's one of the biggest considerations that you want to think about. I think the other one, with respect to like your dependency and your the pipelines that you use, is are they actually using the native pipeline of the operating system, right? Are they using
Oh, yeah.
DirectReady on
Okay.
Windows?
Because
Are they using
you can use
yeah,
Vulkan, for example, on Windows, right? And
yeah,
not code.
Vulkan would be
Yeah.
another
Yeah.
option. The caveat there is that okay, if your editing pipeline is OpenGL4, well, how does that affect a web distribution? Because web, I think it's like WebGL is baseline to OpenGL 3.3 or 330, and so there's considerations for, is this thing even going to render on if you do a web export? Metal and iOS, while they still support OpenGL, it's deprecated. So
Yeah.
if your baseline pipeline's OpenGL, you're
Yeah.
releasing with a deprecated rendering
The
pipeline.
GPU world of things, like in CPU world, like the world managed to create C, which runs everywhere, and like multiple more smarter people than I do. I discussed this, like how incredible it is that C exists, but there's no alternative, unfortunately, for the GPU world.
Yeah, yeah, and then and you have to use GPU code that actually is supported on that.
Yeah,
Yeah, even OpenGL, right? If you use 4.0 features, it's not going to render on a web export, and I think that's an important aspect of the dependency that you bring in, is that uh, it it has to be at least a good citizen in on the OS that it's running on, at a minimum, right?
yeah,
Um,
yeah,
and when I hear about engines that are like, oh, we only do OpenGL export, and it's like, so you're telling me that I'm going to release a commercial game and it's only OpenGL, which is deprecated on two systems, doesn't work on console,
yeah,
and and is a moving target on web, and you're I'm betting my livelihood on this. Okay,
yeah.
that's smart. That's not smart. Don't do that.
Okay. Uh, can we discuss a little bit more in detail? Maybe first the Ruby language and then the
Mhm.
scripting layer. Okay. First of all, like you mentioned, Ruby, in your experience, provided you with the most interesting features, especially the ones
Mhm.
that were helpful to build DragonRuby game toolkit. Can you
Yeah.
speak more to this?
Yeah. So Ruby is a strongly typed dynamic language with really powerful metaprogramming capabilities. So when I say strongly typed, I mean that you can define a class, and you can say, are you a game class or are you a player class? So loose typing JavaScript would be something that's loosely typed, right? So you define a JSON object, or JavaScript object, and it doesn't have a type. You can potentially create a function, but getting the actual, like, does it respond to this function? Is it a derived from this specific thing. Those are facilities that ECMAScript or ES7 doesn't have. TypeScript adds to that, but that's what I mean by strongly typed. Dynamic language means that it allows it the language itself is, I won't say it's not late bound, but it allows for your objects to change at runtime to gain capabilities or or include additional functions or lose capabilities. And and that's probably the best way I can think of speaking to like a dynamic language. So there's no upfront compilation step, and the language is evaluated and interpreted at runtime. So that's the dynamic facilities, or what I consider a dynamic language. And then I also spoke about the ability for Ruby to has strong metaprogramming capabilities. So the idea there is that the ability to change code at runtime is something that's very powerful within the language. So an example is, remember when I did args.state and I did .player?
Yeah.
I mean, I didn't I could put whatever method I want in there. I don't know what properties you're going to define, but because of Ruby's dynamic capabilities, I'm able to construct the method and the backing accessors a la carte, right? I just detect that you want to assign this property, and behind the scenes, that object gains those capabilities. And so that's what I mean from a dynamic aspect of a system. So that's kind of Ruby in a nutshell.
Okay. And then for the metaprogramming, also you mentioned you shown macros, right? How
Mhm.
how how macros work in Ruby?
So a class macro, basically, what a class macro is that you can, for those that are using statically typed languages, you can think of it as like a static class function. So it's a static class function that defines static class functions.
Okay.
So when I do class game and I typed in that attr underscore gtk, I'm saying invoke this function on this class. And when that function gets invoked, what the function does is says, okay, whatever class I'm on, I want you to define args, outputs, inputs, these properties, these helper functions,
Yeah.
and it adds the capability
Yeah.
to a class.
In the world of like the statically I mean compiled languages, for example, like in C, you would have a macro, and then during the compilation, the preprocessor would replace the macro with the physical like lines of code that then would be compiled.
Right.
And in here, because it's interpreted, I guess it happens already on the virtual machine, right?
Right. And the other interesting aspect of these class macros is that I can look at the class to determine what macros I want to define. So if I want to say for every string property, I want to have a safe string, right? That escapes maybe some like malicious characters. So I can say, okay, safe string, safe underscore string this class. And so what the function can do and say, okay, what class am I on? Okay, what properties exist on this class that are being marked as safe string? For those properties, define
Okay.
define another function with the underscore safe at the end of it.
Okay. I would need a minute to wrap my head around this.
Yeah, so you have live access to the structure of the class
Yeah.
at as that macro is executing.
Okay.
So
Okay.
while I think of like C macros and templates as templates, right? They
Yeah.
churn through predefined code. The macro and the dynamic capabilities of within Ruby allow you to inspect the structure of the class as it exists, and
Yeah.
the macro can
Okay.
change conditionally based on that.
Okay.
It's
And
crazy.
yeah, yeah. And so what you're saying now is more akin to like reflection in some other languages, like
Right.
to see like what is the property on this class. Okay.
Yeah.
Okay. Uh, and now the scripting part. For the scripting part, how does it work?
So we we start up our simulation thread. We start up the virtual machine, and then what we're looking for is a file app /main.rb. So that's our entry point. and that's like the single file that you have to have in your script in your scripting layer. So that file gets evaluated. The virtual machine takes that char string pointer, right, and code gens the bytecode, and that bytecode is loaded into the virtual machine. And so after that load happens, we invoke that top level tick args function from there on out. So that's that's like your boot up and startup point. And then what we have is we have a file monitor on our end that is looking for changes to the file system. And for any file that you've required using the required statement, or if it's main.rb, we say, okay, the last modified time was this. It's changed. We kind of shut down the VM, or at the end of tick is where our virtual machine is free of simulation code being executed. At that point, we just hot load the new structures and new code that you've created. So and that's a I guess a facet of Ruby, because it's a dynamic language. You're able to modify class structures dynamically. That's the beauty of it. You can open up any class in the core lib and patch to it. So we are using that facility of Ruby to hot load your code. And so with respect to like game state, um, we're very careful about having like a dedicated, I guess, GC arena for 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 your game state, and we're very careful about when the hot loading occurs, because we don't want to hot load the code while the simulation is executing. We want that to happen out of band when we know that it's safe to patch an environment live. But
So
that's the general
where,
that's the general idea
so
and facet to it.
okay, where, when does it happen exactly?
Right. So you're running at 60 FPS.
Yeah.
So we run your tick, and then we can potentially idle, like if we don't have any primitives that need to be pulled in,
Okay.
or we don't have any inbound network requests for handling. So we invoke your tick, and after your simulation tick has invoked, we're out of the scripting world. And at that point is where we can merge,
Yeah.
as you
Okay.
can say, the environment. And it's just nice. It's a nice facility of having that fixed update, having that time slice for when your code runs, and for when we want to do additional changes to the environment. But that's kind of how this scripting layer works. And if we want to reach into your scripting code, we have the C API to do that, right? So at any point, with for everything that you can do in Ruby, there's a C API on on our end that we can use to invoke things in your scripting layer. So like the reset function that I defined, so GTK reset gets called, right?
Okay.
I'm able to say, okay, that means that there's a reset function somewhere. We want to call that beforehand, um,
Okay.
when we reset game state. And then same thing with tick. So what we're doing there is that we're actually invoking your code through the C API,
Okay.
and
Can,
that's kind of the bridge.
okay. Can we discuss also, because you're working on scripting layer, Ryan is working on, let's say, the SDL part, and there is Alex who is working on
Hmm.
the C extensions, right?
Right.
Can we
Hmm.
cover this area a little bit? How does this
Yeah,
work?
yeah, yeah. So again, our baseline dependency is Clang. So the assumption is that you're using the Clang compiler to if you want to create C extensions. So the idea behind C extensions is you've got a C header file that has specific types defined on it, and if you want to expose, the question is, well, how do you expose that to be invocable inside of your scripting layer? How do I get the C function invoked? So the idea behind the C extensions and how they work is that we've got a component that that generates basically the bridge code that surfaces those C headers into the script runtime. So It's called DragonRuby bind. So you do DragonRuby bind, you give it a header file, and what it will do is it will construct the Ruby objects and the functions that are needed to to provide that bridge. You can do it manually if you like. There's nothing stopping you from just manually constructing your objects, and we have sample apps that show the binding construction, creating your own version. But the idea about and what Alex is handling is this this parsing of of C header files and C code, and then doing code generation that that surfaces that API up.
That's a
And
so like, do I get this right? This is for the, if I want to code in C but use DragonRuby, I can use C extensions, and then I provide my header files for
mhm,
the DragonRuby gen part, which will
mhm.
create Ruby files that will then be loaded in the Ruby mruby, then will then be calling the C SDL. So like the technology wise, we're gonna do like full circle from C to C.
So it actually generates C code. So it doesn't generate Ruby code.
Ah, okay, okay,
Yeah, it uses the mruby C APIs basically,
okay,
and code gens that aspect of it.
okay, okay. Because
Yeah,
yeah, I usually when I see like C bindings and things like that, I think like, oh, the bindings for another language to call C APIs, which are prevalent, right? This is also
right.
for this, but there is like Ruby aspect, but the C extensions go kind of beside that, right?
Yeah, you're basically saying, okay, this C header, I want to be able to invoke this from Ruby.
Yeah,
I want I've got a function called add, and it takes in float,
yeah,
float one,
yeah.
float two, right? So add a b, and what it will do is it will generate the bridging layer to where you can invoke that function from Ruby.
Okay, okay, okay. So okay, so okay, so this is actually what I, okay. So this is Ruby bindings
Right.
in from C to Ruby bindings that you can use in the, okay, 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 makes
Yeah.
sense, makes
Yeah.
sense.
And that's the primary facet of it. Usually C extensions, if you want to like integrate maybe like an embedded database and you want to expose that or have that in your game, maybe like some platform specific stuff that you want that's very specific to an OS. Those are generally when you want to use C extensions. From a performance standpoint, there's there's an obvious benefit to doing logic in C. It's rarely needed though. I would say like it's your escape hatch. Like if you absolutely need something that we don't provide out of the box, or
Yeah,
this must-have feature, you have the facilities to use that escape hash and say, I'm gonna build a C extension.
yeah,
But
but for the most part,
traversing that header file and generating the binding and the
yeah,
actual C binding layer is where LLVM and the compiler toolchain is used.
okay, but for the most part, like, because you can use libraries like fmod for audio and things like that, but for the most part, you're providing audio, right?
Yeah,
So
we're handling all
like
of that.
95% of the use cases that where you would need a C library, you're kind of covering, because you know that people will use this for games, for 2D games, and you're kind of already providing most of it.
Exactly.
Okay, okay,
Exactly. And our community server, our Discord server is where I feel like a lot of these like support things. So if there's like a facility that you actually want, like I I mean, if I if it's a feature that you need for a commercial game, chances are I'm eventually going to need it too, right? So that's it's like just icing on this. So instead of doing a CX, just just send me a message in our Discord and say, hey, I need to be able to do this XYZ thing. Is like, well, why do you need that, or like what are you trying to do? And then facilitate that. And like, okay, we'll just add that function. Don't we'll add it in the next release. Don't create a C extension, please. Just don't trouble yourself.
yeah,
But there's some facilities like I mean, doing from a performance standpoint, C is just fast.
yeah,
It's extremely fast. So those air quotes like critical, or like those like hotspots that you really need a C extension for. That's primarily the usage. I I've I've released 6 commercial titles and I've yet to use a C extension. At least from a from a performance standpoint, like there's it's just not it hasn't been an issue. I think one of our community members was doing like some Perlin noise generation, or Verlet physics simulation stuff that required that facility. Okay.
Yeah, yeah,
Um,
I would guess like very complicated algorithms that you don't have like by out of the box in a game engine, like you know, like physics
yeah,
based or things like that. Okay.
yeah. Or if you want to if you want to generate if you want to render 80,000 sprites with, we have a sample lab that's like, okay, you want to put 80,000 sprites on the screen with collision. Okay, here's how you do it in a C extension if you
Okay.
really need that. But uh, that's kind of where that facility exists. Another facet of it is that when you're looking at just Clang and cross-platform compilation, I mean, like the Nintendo Switch, your PlayStations, their compiler backend, their compiler front ends are all Clang based, and so that's one of the reasons why we specifically say, you know, that Clang is our compilation mechanism or compilation dependency. And
Okay.
so making sure that it compiles across all those OSs, Raspberry Pi, Mscripton is what we use for our web compilation. That's that's where Alex's wheelhouse exists.
Okay. Uh, can we now dive a little bit more into the features? Because beforehand we outlined a couple of features that we can go through to also showcase, first of all, the difficulty, because people tend to have like a simple-minded view of what the game engine does. Especially I do. Like I'm like I can write in a game engine, so
Yeah,
I'd like to hear your thoughts after developing and implementing
yeah.
some of the
So
features.
so if you want to build a game engine, here's the things that you want to think about. All right. So we talked about your render pipeline and your simulation pipeline. Those have to be separate. So if you your your rendering thread has to be free to render whatever it needs to the screen and not be interrupted by an evaluation of simulation. So you need two separate threads for those specific mechanisms. Audio will be again on its own separate thread, and then if you have network I/O, we do like HTTP for network access. That will need its own background thread to work, and all those things synchronize into your simulation on completion. So you've got your threading model. One of the other things that people don't necessarily think about, export is the other thing. We talked about Clang and uh, targeting your Mscripton and all that stuff. So we've talked about compilation. Your rendering backends have to be OS specific. You can't, please, if you're going to build a game engine, don't think you can just do OpenGL and it's OpenGL 4.1 and it's all going to work. Please don't do that. For a hobby thing, go for it. But for real commercial games, it's you're it's a big risk, and you're delivering that risk to people that use that engine. It's it keeps me up at night. So we've talked about rendering, um, aspect ratios and high DPI.
Yeah.
Just if you think about like an ultra wide display, or like even Android devices with 19 by 5 by they don't have the 16 by 9, they have like 19.5 or 24 by 6 resolution. So you load up a game, how does it scale, right? I've seen, not to pick on Unity, but just because I've done it in Unity, I'll create a game like, all right, I'm ready. I didn't think about my aspect ratio, and I've just used the default camera, and I loaded onto, a wide Android device, and it's just like stretched from
Yeah.
edge to edge, and the scale and ratios is wrong, and it goes into the notch, like you'll have those like little dead spaces, or it's not in the safe area. So when you think about rendering, you're basically saying, okay, the mental algorithm you're doing is, all right, what is the width and height of the screen, and given that ratio, what is the best fit for to retain the 16 by 9, And after you get that best fit, that gives you your kind of like, it'll give you your logical center and then your offsets on your like letterboxes on your left, right, and
Yeah.
top and bottom. Now that you have that, you can say, okay, your center, your game is centered in this uh, in this retained aspect ratio of 16:9 with bleed on edge to edge. So you're good there. But now you have to think about, okay, what is the DPI of the device? So your logical scale is, 1280 by 720, but now I'm running on a screen that has, let's say, some resolution of like 2000 by 1500. So if you think about that aspect ratio, 1440 is your best fit. So you have to think about, okay, is 720, if I did my native resolution at 720, is that going to fill the screen? No, it doesn't. Okay, what if I go to 1080? Does that fill the screen? No. All right, now jump up to 1440. And then that's your and then you're like, well, what about 4K? And then you find that it leaves off the top and bottom. So okay, so now my best fit is 1440p. So you have to think about, you have to determine the aspect ratio. You have to think about the DPI, which is potentially different than what the operating system supports. I mean, reports as far as the resolution. So you have your DPI, and you say, okay, for this DPI, the resolution, the native resolution is actually 4K, even though the logical resolution is, whatever uh, the platform reports. So now that you have that information, your rendering has to go to that scale. So when your logical resolution is saying put something at at pixel 1010, well, you have to convert that to the native scale of the device. So every property, every value gets multiplied by that native scale. So 1010 ends up being, at 2x would be 2020. At 4K, I think it's like, 8x that resolution. So that gets taken into consideration. And then you're looking at texture atlases. It's like, okay, now that I have that, now that I have that native resolution, what's the convention I'm going to use to provide the correct texture atlas? One of the biggest challenges we had with respect to rendering on different devices was um, Android's maximum texture size that can be loaded into its GPU is 4,000 by 4,000. So you have,
Okay.
yeah, so uh, there's a common, it's a really bad error and misconception. We'll say, oh, pack your sprites so you can handle
Yeah,
the
yeah,
performance. Like,
yeah,
no,
yeah.
DragonRuby handles that. Don't pack your sprites, because if you create a 6,000 by 6,000 pixel sprite sheet, that can't load on Android. It will not work. So you can't do that. So we have, those are the things that we have to think about with respect to loading your textures and how we pre-cache everything. And if we warn you, like you bring in a PNG that's larger, you create a virtual canvas that's larger than that size. We say, hey, this will not render on Android or web mobile, because it's past the limitation. So aspect ratios and high DPI rendering was brutal. Was
Yeah.
abs And the thing is that it has to work, right? Yeah, you can you can put your configurations in the engine to say, if Android, then do this scale. But I don't want to waste my time doing doing those kind of things. So that was there was a lot of work putting to making sure those aspect ratios come in. So multi-threaded compiler dependencies, scripting layer, aspect ratios, and high DPI rendering, compilation and export. What other font rendering is another painful. We
Yeah.
use from our dependencies toolchain, we use STB TTF for
Yeah.
our font scaling. But even when you think about font scaling and getting sizes of glyphs and pre-caching those textures, again, you have to think of high DPI and those facets. So you say, I want to render this font at a height of 50 pixels. Well, that's 50 pixels at 720p. What is that height of the glyph
Yeah.
at 4x scale or high DPI scale?
Yeah, and
And
it's like
so,
with high
yeah,
DPI, it's also like it's not that like the window will be twice as big, right? It's just the
right,
same size, but higher, so like higher resolution. So like if you just
Right.
scale twice, it has like
You can't do that.
twice as big on the
Yeah.
same window size, and then like for a phone, it makes a huge difference, right? Whether it takes up like 15%
Yeah.
or like 30% of the screen. So you just can't do that. Like whole dilemma, like the mobile scaling. Okay, I don't envy you like the math that you needed to do, and also like
Yeah.
it's it's so unconstrained in terms of like aspect ratios, for example, right?
Yeah. And the thing is that from my perspective, that's the role of a game engine, right?
Oh yeah.
Is to handle that stuff for you. You shouldn't have to think about that. You should be able to build your game and release it and see it work on every device that is claimed to be supported. Um, and that's a just a really important facet. So yeah, a lot of work was put into getting those factors in, but it it's I stopped game development for 2-3 years because I was like, if I don't do this, if I don't do this, I'm gonna spend the rest of my the rest of my time on upkeep of all
Yeah.
these games, and it's just and it's done. Thankfully, thankfully it's done, and now you can just reap the benefits. Uh, like there my revenue distribution like between platforms is almost an even split on iOS, Android, and Steam.
Oh,
So
okay.
so Steam and console. So like you're if you're saying I'm going to release a game and I'm only going to release it to Windows, you're leaving 66% of your revenue on the table, right? And every dollar, especially as an indie, every dollar counts. And it should be trivial. It should be trivial to release cross-platform. Um, and like native builds for Linux are really important for Steam Deck with the Steam Deck release. But um, but yeah, I think that the aspect ratio and the font scaling that was that was that was not fun. That
Yeah.
was not fun.
Yeah. Look, we've been, I think, going for like 90 minutes in
Hmm.
very technical and heavily technical aspects. So let me
Hmm.
ask you, a little bit reaching the end, uh, more personally about your history of making games, a dark room, and
Yeah,
how does it look like for you?
yeah. So I think just as like a parting thoughts kind of thing into segue into this. Like one of my philosophies, and I think a philosophy of the Dragon Ruby community. It's kind of like in our read the rules section is be the person you needed, your past self needed, right? So that's who you want to be. You want to be the person that your past self needed, and a facet of that is what describe the philosophies of what Dragon Ruby does and a lot of those things. And so what how I can operate now and how I wish my past self could operate is I'll start prototyping. I start You get a game idea and you start prototyping a game. And so my pre-production or the idea of pre-production or how I start building out a game is I go for a 20-second demo. And the idea of that 20-second demo is you need to be able to communicate why your game is unique and why the players should continue playing within that 20 seconds. So from live ops or from like a retention rate, your fall it's surprising, but your fall off rate is 20 seconds for a player. So if someone downloads a free game or a demo, they will play for 20 seconds and you'll have over a 90% fall off rate after that 20-second period. So when I prototype something or I'm thinking of an idea, that's what I start with. It's like, okay, what is skip the menus, no menu screens, no presented by or any of that. Get right into the action and tell me and see if you can communicate the hook or why I should continue playing the game in 20 seconds. I'll start with that, and then if I like the idea or if I like the mechanic or I like the hook, then I position myself to uh, potentially join a game jam and expand on the idea to get good faith feedback. So if you think about, just releasing a demo and trying to get feedback from external beta players, it's rare that that happens. So I have this idea that I want to explore. Then I expand that into a longer period of time as in a game jam. So if I find a game jam that fits the theme, that fits my idea, I was like, okay, I'm gonna this idea that I had in pre-production, I'm gonna create a more filled out experience, and I expand on that 20-second demo. And so I released to the game jam and kind of see how it does in the game jam. Ludum Dare is one of the ones that I frequent. And I had this idea for it's called Urinal Simulator. So the idea is that you're
Urinal?
managing Urinal Simulator. So you're managing the allocation of people that need a pee to the urinals that they go to. And there's urinal etiquette, right? You got to put a space. Like if someone's peeing, you don't stand right next to them. You go like at least see you're
Yeah.
smiling. So I wanted to build a game called Urinal Simulator, and so I was like, okay, I think this idea will work. So I actually submitted this to Ludum Dare like the last one. I got ninth place. I got ninth place under humor and fun category. It was awesome, but but um and it got good feedback. So I was like, okay, this is potentially something that I could expand on. And it was funny. It got to the point where you're allocating urinals and they get dirty. So then you have to buy robots to clean the urinals, and then zombies start attacking. So then you have a gun that you use, and then you start shooting zombies to keep them to protect the
How
people that
much? How much of that is in first 20 seconds?
the first 20 seconds was just the Euro
Okay.
allocation.
Okay.
So the my first 20 seconds and what kept me wanting to play was the PP dance. So when you're standing there and the person standing there and they're getting to a point where they're like, I need to go, they start like dancing in place and going
Okay.
back and forth. And I was like, this needs to happen. This needs to be created. So like the visual aesthetics is something that can contribute to that idea of wanting to continue. So then that's when I expanded it into the prototype. And after the prototyping period is where I commit to saying, okay, I want to release this as a commercial sustainable product. And my time frame is 240 dev hours. So you can think of that as 3 months, working 3 months on a game part time,
Part time, how many hours? Week?
20 hours a week.
Okay. Okay.
So you need to have something that can be can be released as a air quotes complete game in that period of time. And as an indie dev, as from a standpoint of sustainability, this is how you're testing the market, right? So an example is I watched an anime called Initial D, and it's a great freaking anime if you've never seen it. But it's an anime about this like old Toyota Corolla that races like all these crazy cars, and it does this like amazing like drift, and the guy that driving is like drifting around corners, and he's building like beating like RX-7s and R32s and just crazy. And I was like, how is he so good? So I built a game, and I called it A Car That Turns, and it was around this idea of uh, driving this Toyota Corolla, it's an AE86 down the mountain passes within the anime. So the first 20 seconds was I need to get the feel for the drift, right? That first turn, how did that feel? And once that felt good, then I did some game jams with it, and people liked the drifting aspect. And then my first release was one track. So it was one track, one iconic track from the anime, and within that 240 40-hour dev period. And during that development cycle, I start air quotes marketing the game. But the facet for marketing my games, or the approach that I take, is that I'm not looking for like a general market. I'm not trying to make a generic game or a clone of an existing game but better, right? I'm saying this game is for people that love this anime and are just big fans, cult following. And
Cultists.
so yeah, it's a cult following. It's great. But the anime came out like 20, 30 years ago. You need to watch
Oh,
it. It's
okay.
great. But so when I go to marketing, I go to their subreddit. So I'm not going to r.game/game dev
Yeah.
or r indie games or r gaming and trying to do whatever, you know, growth hack of like, hey, I found this weird game. Like, hey, I go to their subreddit and say, look, I'm an indie game dev. I love this anime. and here's here's my car. This is what it looks like. This is my favorite episode. By the way, I'm building a game, and I start posting and saying, okay, I've gotten this track. How do the visuals look? Try the game out. And for that initial release, I'm releasing to itch.io. It's web playable, right? So having a game that doesn't need to be downloaded and
Oh
can be
yeah,
played
oh yeah, oh
online
yeah.
is important for game jams, and it's especially important for that initial release. So I within that 240 hour period, a dev time period, I released the game to itch, have it playable for free, and then because it's that single code base, I'm releasing to PC, Mac, Linux, Steam, iOS, and Android. So then my call to actions are, hey, you can play this on mobile, you can play this on iOS, and it's available on Steam. So your lead in, you're marketing to this niche audience. Your lead in is your itch page, which is mobile playable, which plays on touch devices. People visit websites on itch.io. It's playable there, and they get a taste for what that game feels like. And then from there, that's your call to action, your conversion rate for actually them purchasing the game. And at that 240 hour dev hour period when I release, that's when I decide if I want to devote more time to it. So maybe it's just a free game and I leverage the assets for a future game, or wait, it's getting good reviews. I'm going to add another track and add more content, and then that's my decision point on whether the game is an air quotes failure or if it's something that's worth worth adding to.
Yeah.
And that's kind of my flow. So I have ideas. I have idea. I work on DragonRuby. I have one game, and I have many games in pre-production. But one game I think I'm actually going to commit to for a longer period of time. That's went through this facet of
You
I've
know,
tried it in game jams. I've done the prototype,
this is
and I
super
want to commit.
smart. This is super
Yeah.
smart. Like, because usually it's split in two, right? You make prototypes, and then at some point you say, okay, this prototype, we go full production on this prototype, right? You have like four stages if I counted properly, and if you don't like the prototype, you ditch it very soon, right? Then you
Yes.
expanded it to game jam. In game jam, you get bad feedback or like feedback that the game uh, does not perform well in some aspects. You can still pretty like you did not commit so much time yet,
Exactly.
right? You can again come back, then you're expanding it more. Like you have like this four cycles, and this is incredible because it lets you iterate so much, and your games are so unique. Like they're so different than what's out there. Like you
Yeah.
can feel that it's not like let's take this title, switch a title, and change the graphics, right? It's
Yeah.
yeah, one of maybe let's you should plug, by the way, your games now.
Yeah, so a bunch of games out there. So I ported. I did a port of a web-based game called A Dark Room, but I did a mobile adaptation and the commercial adaptation to that game. A lot of narrative and pacing stuff that was in there. So that ended up doing real well. I created a pre-sequel to the game called The Ensign. That was in like 2014. Then I created a new air quotes franchise or what have you, and it's a rhythm based top down 2D platformer based on uh, a novel written in the 1800s called Flatland Romance of Many Dimensions. So it's about a 2D world. And so it's a satirical commentary inspired by Flatland presented as a rhythm based, top down 2D game. And it's called a noble circle. So you play as a 2D circle, and it's as stupid as you think it sounds, but they're so they're niche in that perspective, and so after that I created mildly interesting RTS. And so the idea there was like, I love StarCraft, I love RTS, I just don't have the time, and I'm just too old. I can't even beat like an easy AI anymore on StarCraft. It's really bad. But I wanted something that encapsulated the fix. I wanted my RTS fix, but in 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 the context of a busy adult life. So I created a mildly interesting RTS, and it condenses down and simplifies the idea of like what we get out of RTSs, and ended up releasing that. It's funny because I posted about it, and Jonathan Blow actually dissed the game. He was like, "This game is. I mean, look how shitty this game is." I put that as one of my quotes. It's like, "Look, Jonathan Blow said my game was crap. You should definitely play it." But again, it's that hyper niche aspect where you're looking for a specific group of people that will immediately connect to the ideas in the games that you're building. And so that's what mildly interesting RTS was. It's for the busy person that doesn't have the time but grew up playing and loves RTSs. After that was a card that turns, that it's my target revenue for my games, and the reason I have these small timelines is 5,000 per annum. So I'm looking at a target revenue of 5,000 per year. I'm not looking for millions of dollars. What I'm looking for is these hyper niche, long tail experiences and building many of them. So please don't spend 3 years working on a single game as an indie. Please, please don't do that. Please don't do that. Please don't do that. If you're releasing for commercial release, you have to be able to iterate, fail fast, and your target has to be realistic. You have to say, okay, you're 50% of games on mobile don't even get downloaded. 90% of games make less than 10,000 per year. So if you take the 1 billion some odd games, on all these stores, their revenue potential, you need to have realistic expectations. So my revenue band is like 5,000 per year. So over a many year period is the premise. So if you think about 3 months part time working on a game, I'm air quotes making 4 games a year is what you're potentially thinking about. And then you cross promote your games. So if someone downloads your game, chances are they'll like your other games. So you get a lift there. But you're looking at, okay, maybe best case 20,000 per year, but that's that's a rent payment. Like that's not a non-trivial income. And then once you get up to 12 games, that's that's real money.
Yeah,
Not
also,
everyone's going to make $5,000. I get that, but it's this idea of these small iterations and targeting and catering to these hyper niche communities that large companies and generic games will never try to capitalize.
yeah. It also seems like a lot of indie developers target PC, maybe consoles, and you're targeting mobile. And mobile, I think, is very much dominated by the big players now. And
Yeah,
this is why like you have a different strategy here, maybe unconventional one, where but like targeting niche or like specific group, I wouldn't call it's like a I wouldn't call unconventional, right? Like you need to do that if you want to have an indie game from person who is not known and doesn't have a
right.
couple of million in the pocket
Yeah,
for the
and
marketing for a mobile game.
yeah, and from a platform standpoint, initially the target when I first started was mobile because I was like I want to learn mobile development, but the I I mean it was the ensign when I released it, initially, it's still not on the other platforms. And I look at the revenue potential that I've lost over the last 9 years. If I released if Dragon Ruby existed back then, I was able to release cross platform, PC, Mac, Linux, Steam, web. I like so much money has been left on the table, and so there's a niche facet of it initially started on mobile, but your revenue potential increases, you know 1x for each platform you distribute to. And there's some growing pains on, like, okay, how do I make this nice and playable on a touch device, or how do I get this playable on a very small screen or a handheld device. There's some growing pains there, but it it pays back. It pays back. And the thing is that if you want to have any chance of going to console, they're going to ask these questions, right? Have you released to a handheld? Do you understand the facets of dealing with ergonomics that have this duality of touch and controller? And it's even more important with the Steam Deck coming out.
Yeah.
So, and then when I talk about niche, another community I'm part of is mechanical keyboards. So
Okay.
who cares about building keyboards, right? But I will build a game called keyboard simulator or keyboard building simulator, the number of people that want to play that game is extremely tiny. But it's a unique facet of, yes, it's a niche, but I'm thinking hyper niche. Like, think about those people that love basket weaving. If you love basket weaving and you want to
I
build a
don't know
game
what
about
it
basket,
is even. Can you tell me?
basket weaving is you take
Oh,
straw and
weaving.
make a
Okay,
basket.
okay,
Weaving, yeah,
okay, okay, okay.
basket weaving. Um, People spend tens of thousands of dollars on training falcons, and there's like falconeers that it's a hobby, but they don't have a video game about training falcons, and they will pay for this because you're going to them and you're saying, I'm an indie dev, I'm a human being, right? I'm Amir, and I love this anime, or I love this hobby, and I'm
Okay,
building a game, and
okay,
so that's important.
okay,
But yeah, that's kind of how I approach game development these days.
okay. Amir, I think we're reaching 2 hours now.
Yeah,
That's a good.
yeah, I
That's a
think
good
we're
time.
good.
I think will be. It will be the longest episode this channel so
Wow,
far.
wow.
So, any
Hopefully
closing?
the content was good. It was interesting.
Oh yeah. Uh, any closing thoughts?
um Follow your dream. Like, dream big, start small, right?
Okay.
Dream big, start small. And obviously, anyone that listens to this YouTube video, whatever, if they send me an email saying that I heard about DragonRuby, I'll hook you up with the license. So we do freebies here and there, but if they reference your stuff, um you know just send me an email, and I'll hook them up, no
We'll put
problem.
also all of the links, required links
Yeah,
in the description so that
yeah,
everybody knows who
yeah.
to
I want you
contact,
to
where to
succeed.
go.
I want you to be able to follow your dream, right? This is why we got into programming, was that we were kids and we wanted to say, I want to build a video game. And that's how I started.
That's.
And
I think that's a lot. A lot of people started
that's a lot
this
of
way.
people.
Yeah.
Yeah. And
Okay.
it's wonderful. It's a wonderful thing. And I want you to be able to do that.
Great. Great. Thank you so
All right.
much, Amir.
Yep.